Okay, this will just be a quick review of exit slip number 10, where we worked on using properties of logs and then also solving equations involving logs and exponentials. So the first problem we're looking at asks us to condense 3 logarithms into 1 logarithm. And before we do that, let's just refresh on the 3 properties of logs that we'll be using. So we have a property that says if 2 logs of the same base are being added, we can compress that to a single logarithm where those quantities are being multiplied. Or, of course, I could say that same property in reverse. If I have log base b of a product, x times y, I can bust that up into the sum of the 2 pieces. Our other property says if we have log base b of x minus log base b of y, that's the same as log base b of x divided by y. So that direction that I just read through sounded like compressing, but as we go through these properties, I just want to make sure we can move them both ways. So I can go from the left side to the right. That would be a compressing direction. If I change my direction and go from the right to the left, that would be more of an expanding direction. So just watch out for the directions. And then the last property I have here is if we have a number times log base b to the x, we can push that up as the exponent to arrive at log base b of x to the power of r. So we typically refer to these first as the product property, then we have the quotient property, and then the power property. In some problems you'll use all 3 properties, in other problems you may just use one at a time. So let's go back up to that problem from the exit slip, see if we can put these properties to use. So in this example we are condensing, which means we'll be moving from multiple logs to a single logarithm. I'm going to show some steps, although you may choose to just jump right to your compressed answer. But one step we can start off with is moving these values out front up as exponents. So I can move the 3 up as the exponent on x, the 1/2 up as the exponent on x minus 1, and the 4 up as the exponent on x plus 2. So just showing that much, we're at log base 7 of x to the power of 3 added with log base 7 of x minus 1 to the power of 1/2, and then that's still being subtracted by log base 7 of x plus 2 to the power of 4. At this point, one other thing you may do that you'll often see done in textbooks is the power of 1/2 on my middle logarithm is the same as square rooting. So remember, for example, if I said the square root of x, that's the same as x to the power of 1/2. So with that in mind, I'm just going to go ahead and take one more step of rewriting this as log base 7 of x cubed plus log base 7 of the square root of x minus 1. That's a little bit more common way you might see x minus 1 to the 1/2 written. And then still minus log base 7 of x plus 2 to the power of 4. Okay, so at this point I'd like to highlight just this plus here, because that's going to tell me how to compress these first 2 logs. I'll also highlight this minus at the end. So I will go ahead and take these next 2 steps together, but if we have the first 2 logs being added, that really implies I can multiply those quantities. So I can multiply x cubed coming from this first log with the piece coming from the second log, which is the square root of x minus 1. So you see my addition compressing to multiplication. Next, I'm subtracting log base 7 of x plus 2 to the 4th, which means I can simply divide by the quantity x plus 2 to the power of 4. And that would be a great way to leave our final result. We have condensed the logarithm as directed so that it's just expressed as a single log. So hopefully that feels fairly comfortable. This direction of condensing is in the long run most valuable when we move towards solving. And solving is exactly what we're doing on this second problem. So this one asks us to solve 7 to the power of 3t equals 100. If we stop and consider for a moment what our technique will be, my thoughts are something like this. I'm thinking about 7 to some powers real quick. So 7 to the first is 7. 7 squared would be 49. 7 cubed is 343. So kind of the point, I guess, is that if we have 7 to some power in this instance equaling 100, we know the exponent on the whole is going to fall somewhere in between 2 and 3, since 100 falls somewhere between 49 and 343. So just to have a little bit of an idea walking into the problem, what our solution will be. Of course, our exponent is a 3t, so 3 times t will be something between 2 and 3. So I can't use the method of equating the bases to solve here because 7 and 100 can't be expressed as the same whole number base. So we can approach this one using logarithms. If we take the equation 7 to the power of 3t equals 100, and we take log of both sides, really log of any base, I'll just go ahead and use natural log. As I introduce natural log on both sides, that will allow me to then use my power property for logs, which says this exponent can be pulled down out front. So now we're looking at 3 times t times the natural log of 7 is equal to the natural log of 100. Natural log of 100. So to finish getting t alone, t is what I'm solving for, I'll just divide on the left-hand side by 3 natural log 7. That will get t alone. So we'll divide the right by the same. And that will give us in exact form that t is equal to the natural log of 100 divided by 3 times the natural log of 7. In the homework it does ask for exact solutions, so this would be the exact solution. So right here, this is good as far as the homework goes. For the exit slip, it did say round answer to the nearest hundredth, so if you carefully type that into your calculator, I think we get back about 0.79. One word on using your calculator is just be careful with the use of parentheses. So you would want to type it in as ln of 100 divided by, and then you'll need a big set of parentheses for the bottom for most calculators. So just try it out on yours and make sure you can get that same approximate value of about 0.79. Very quickly now, going back to our logic check from the beginning, if I think about taking this solution of t is approximately 0.79 and plugging it in as the exponent, I can make sure that 7 to the power of 3 times 0.79 is approximately 100. And I'll leave that to you to verify, but it looks like that should work out. So hopefully that helps. Make sure you start in on the homework. There's a good amount, but you can always ask questions on Canvas.